would you like to do the last minute revision for your PPT, or you are perfectly okay with your current PPT now? Is that okay? Perfectly okay, thank you. Okay. So let me do a brief roll call here. So let me do a brief roll call here. So Sendai Seiryo Secondary School, Japan, are you here? Let me see your hands. Sendai Seiryo Secondary School. All right, thank you. Waseda University, Honjo Senior High School. All right, thank you. Honjo High School, Seri, Malaysia. Are you here? Okay, next one. This one, Cheng High School, Malaysia. Cheng High School. All right, sure. So everybody for the session 2, the afternoon session is here. So we are going to begin shortly. So please be seated. All right, so good afternoon, honorable guests, presentation teams, and students. We hope you enjoy a refreshing lunch and you are feeling well rested. Before we begin, please be noted that each team has 10 minutes to showcase your ideas. Our staff will hold a play card to remind you of the time, 3 minutes and 1 minute before your time is up. When you read the play card showing time is up, please finish your presentation immediately. The microphone will be turned off at the same time. For this session, we are also delighted to be joined by a commentator. Please allow me to introduce him to you. So, Dr. Du Yichun from Cheng University. Thank you. Thank you. So let's get started. The first school for this session is Sendai Seiryo Secondary School from Japan. The topic is Secrets of the Seiryo Forest, a scientific investigation of foam and oil fame in the Umeda River. So let's give them a big, big round of applause.
Hello everyone, we are the science class from Sendai Seiryo Secondary School. Today we are honored to be here and present on the theme, Secret of the Seiryo Forest, a scientific investigation of foam and oil-like film in the Umeda River. Our research focuses on a mysterious phenomenon we discovered in Seiryo Forest, our school forest, and that Umeda River that flows through it. First, let us introduce Seiryo Forest. Our school is located in Sendai City, Miyagi Prefecture, northeastern part of Japan. Next to our schoolyard, we have a green forest called the Seiryo Forest, and the upper section of the Umeda River, light flows through it. We have always enjoyed this rich natural environment at school, but one day, we happened to see a mysterious phenomenon at specific locations along the river. We found the calm area of the river were covered with a lot of white foam that is created when a stream drops down to a lower height. We found an oil-like shiny film floating the surface of the water in different areas. How would you feel if you saw this? Looking at the foam on the left, you might think, did someone dump detergent? Looking at the film on the right, you might wonder, is oil leak from construction site? Many people would associate this phenomenon with environmental pollution caused by human activity. However, is this really man-made pollution? To solve this question scientifically, we set two research goals. The first goal is to assess the water quality of the Umeda River, which originates near our school. By monitoring water quality over a long period and comparing upstream and downstream areas, we will check the condition of the river. The second goal is to find the cause of foam and film and determine whether they are man-made or occur naturally.
First, let's look at the water quality survey at the top of the Umeda River flowing from Seiryo forest. We set up 3 monitoring sites, A, B, and C, and conducted regular and continuous water quality tests with different characteristics using denser pH meters and pack test. If this pollution is caused by humans, the water data would show unusual results. For example, the pH level can become extremely acidic or alkaline. Also, the levels of ammonium and nitrate ions tend to spike. However, our results showed that the pH level was always neutral between 6.5 and 7.2. Also, the levels of ammonium and nitrate ions, which show pollution from household wastewater, were almost zero. Therefore, we found no conclusive evidence of man-made pollution. This suggests that the river is chemically clean despite its dirty appearance. We also conducted surveys in the midstream and downstream sections of the Umeda River. This point on the map is Seiryo forest. The photos and map correspond to each other by color. No conclusive evidence of man-made pollution appears to be present even in the downstream area passing through the city. However, even in the downstream area, similar foam was routinely observed just like upstream. Since the water quality is normal, we believe this foam is not caused by man-made pollution. Instead, we suspect it occurs naturally, just like the foam in Seiryo forest.
Next, let's look closer at the true nature of this foam. This microscope image of the foam shows a clear difference in structure between detergent foam and the river foam, confirming that the cause is not humans. Therefore, we thought that some natural dissolved substance in the water act like detergent, making the foam stable and long-lasting. We suspected that this substance might be polysaccharides, which are complex carbohydrates made of linked simple sugars like glucose, and they are also produced by plants. In other rivers where similar foam is found, studies report that these algal polysaccharides are the main cause of the foam. But why do polysaccharides act like detergent? Our hypothesis is as follows. Some naturally dissolved substance in the water release polysaccharides into the water. This makes the surrounding water a little more viscous than usual. Then, when air mixes into the water, when the stream drops to a lower height, it forms bubbles. Because the water is sticky, these bubbles don't burst easily and build up over time. In short, these algal polysaccharides are the reason why the foam lasts so long. So, where are these polysaccharides coming from? When we investigated beyond the area where the foam occurred, we discovered an area where the bottom was completely covered with algae. By observing these algae under a microscope, we found a lot of tiny water plants. By observing these algae under a microscope, the algae shown in these photos are well known for producing a large amount of polysaccharides. These diverse algae, living in a rich ecosystem, release polysaccharides that act like natural soap, producing the river foam. Since these species produce polysaccharides, we concluded that the cause of this foam is the polysaccharides from these algae.
Next, let's look at the other mystery, oil-like film. If real factory oil or crude oil leak here, it would cause terrible damage to the nature. However, we notice some important difference between this oil-like film and actual oil. First, it has no smell. Second, when you stir it, it stays separated, unlike real oil. Real oil would reform itself and become smooth again. However, this film separated into irregular pieces like glass and never reformed. Based on this, we concluded that it was highly unlikely to be man-made oil. Then, what is the true nature of this film? We know the answer lies in the activity of iron bacteria. In fact, a previous study by our senior showed that the bacteria exist around the Seiryo forest. Iron bacteria are tiny microbes that live in water. This illustration shows their ecology. When iron bacteria oxidize iron, they make an insoluble precipitate called ferric hydroxide. As this forms a very thin film on the water surface, the diffuse reflection of light creates a beautiful iridescent rainbow-like luster that looks just like floating oil. In fact, under microscopic observation, we found that the bacteria responsible is highly likely Leptosphyx operacea, a type of bacteria known for its unique straw-like shape. In short, the oil-like film isn't pollution, but is actually the result of active iron bacteria. Finally, let us conclude our presentation. We did a scientific study of our local river looking at the foam and oil-like substance floating on its surface. As a result, we discovered that the foam which appeared to be detergent pollution is actually caused by polysaccharides released by algae. Similarly, the film which looks like an oil spill is a natural phenomenon resulting from iron bacteria. We often assume that an area is polluted based on visual impression alone, blaming human activities. However, we believe that clearing up misconceptions about our local environment is essential. Using science to look at nature is a critical first step toward building a sustainable local community as envisioned by the SDGs. Here are our references. Thank you for your kind attention.
Thank you. So for the next team is from Waseda University, Honjo Senior High School, Japan. The topic is river environment in Honjo City, insights from river research. Let's welcome them.
Hello everyone. Have you ever seen this creature? Please raise your hand if you have. Thank you very much. More people than I expected. It is crayfish that is famous in Japan as non-native species or alien species. It comes from other areas and bad effects on the environment and ecology. Like this, there are many problems related to rivers in Honjo City. So, I'd like to talk about river environment in Honjo City, insights from river research. We are river research group of Waseda University, Honjo Senior High School. I'm Takuto, and they are Rinko and Saki. We have 4 main topics about our group, methods, results, and finally, potential and improvement as a conclusion.
Now, I will introduce our group. Our group is called Kuen. Kuen is a project team of our school to keep the river environment. We started in 2009 and we have conducted our activities. As you see, we have expanded our activities. Let me explain the objective of our project. That is, improving river environment in Honjo City. It contributes to SDGs goal 4, 6, 30, and 14.
Next, I'll explain our method in 3 parts: river research, water quality, and ecology. First, about river research. We research at Koyama River in spring and at Motokoyama River in autumn. Koyama River has the best water quality in Honjo City, and Motokoyama River has the worst one. Every year, we enter the river and catch the river creature with students of Fujita Elementary School. Next, about water quality, we use 3 items. First, dedicated device to measure DO, pH, and water temperature. Second, pack test to know the numerical value of chemicals. Third, publicly available BOD data. About ecology, we use data between 2009 to 2025 and focuses on indicator species and non-native species.
From here on, we will share with you our result and discussion. We will talk about it in 4 parts: water quality, water temperature, non-native species problem, and environmental hormones. First, water quality. We used 3 sets: BOD, DO, and pH. About BOD, the higher, the worse. About DO, the higher, the better. pH indicates the hydrogen ion concentration and whether a substance acidic or alkaline. Now I will show graphs. These are BOD graphs. Left graph shows spring data in Koyama River and right shows autumn data in Motokoyama River. Both have shown a downward trend, and all data have also been less than 5.0 since 2008. Next, DO graphs. Both have been increasing. Almost all data are more than 7.0, so these rivers are great for fish. Last is pH. We have less data in spring, but almost all data are in 7 to 8 and have been stable.
Let's check indicator species. We classified 4 groups like this. For example, if we collect many crayfish, it shows the river is very dirty. On the other hand, if we don't, it means the river is not dirty. In this case, crayfish is an indicator species. These graphs, the sum of blue and light blue shows the percentage of clear river creatures. In the last 3 years, we didn't have many rainy days before river research, so the percentage of clear river creatures is less than other year. Except the 3 years, it exceeded 70% in most years. It means water quality in this river is not worse. In summary, we can say clearly from the data that water quality has been improving. However, it wasn't just a good thing. Take a look at these graphs. As you see, water temperature has been rising. Given the air temperature affects water temperature, we thought it is because of global warming. Why is it worse? Because it can cause non-native species problem. In fact, percentage of non-native species has been increasing. It is because some of non-native species came from other warmer areas, so these creatures used to be warm water. Also, our senior did a starve experiment and found non-native species live longer than native species in a harsh environment. This is one of the reasons for increasing the number of non-native species.
Lastly, I will talk about environmental hormones. Have you heard of them? It is harmful substance for creatures. One effect is feminization of creatures. Now, please look at this graph. We focus on EE2. E2 is short for ethyl estradiol. It is chemical that acts like a female hormones. We measure environmental hormone levels at Koyama River. Our school is here, and Koyama River flows around there. And point 1 is located up upstream. As shown at point 1, places with a higher percentage of female shrimps tend to have higher EAT levels. This may be because point 1 is an area without storage system, so domestic wastewater can enter the river directly. However, BOD, DO, and pH didn't show the effects of environmental hormones. Therefore, it is important to consider not only water quality, but also the ecosystems. In conclusion, water quality in Honjo City has been improving, but the ecosystem needs more time to recover. In other words, good water quality does not always mean good ecosystems. Protecting rivers needs many approaches. Some topics are difficult for high school students, but they are important for understanding environmental protection.
Now, I will tell you our project potential. First, Kuen works with elementary school, so our project nurtures people who are responsible for the future. Second, we have continued our activities for a very long time. Kuen is 70 years old this year. I hope long data help us to understand and improve the river environment. Finally, our project affects citizens because we cooperate with Honjo City and hold a symposium every year. Also, with the help of the city, our activities are expanding.
In the future, we hope to improve data accuracy using the environmental DNA and expand international collaboration. For example, Tainan First Senior High School and Miso Tomoyankun project with Mahidol High School. Kawaken is supported by many people. Thank you very much. I hope Kawaken will continue in the future and contribute to creating a sustainable society. Thank you for listening.
Thank you very much. So the next team is also from Waseda University, Honjo Senior High School, Japan. The topic is environmental education, collaboration with elementary school. Let's welcome them.
Good afternoon. What is your most memorable lesson in your elementary school life? What do you think?
For me, making river in the sand.
That's good, thank you. I believe that memorable lesson in elementary school may not change your life, but they can broaden your interest in various fields. So we conduct lessons in elementary schools to get the students' interest in the environment. We are from Waseda University Honjo Senior High School. I'm Sakura Tokuzawa.
And I'm Yuika Terai.
Today, we will present our activities, environmental education. We are going to talk about introduction, survey process, results, and future works. In recent years, the environmental problems have been getting attention. We believe that knowing, thinking, and sharing about them are important to solve these issues. From this opinion, we, the Labor Research Group, conduct lessons and researches delivers with grade 5 and 6 local elementary school students. The contents of our lessons are about the environment, local livers, math, science, and presentation skills. Next, I will talk about our history. The Labor Research Group started in 2009, and our relationship with elementary schools began in 2012. Our activities were restricted by COVID-19, but we came up with ideas such as making a picture book about creatures in local labors, and have continued activities on this day. In recent years, we have been trying new things like collaboration with overseas schools and using the environmental DNA.
To evaluate the effectiveness of our environmental activities, we conducted surveys with elementary school students and teachers. I will describe the survey detail. We conducted 4 surveys. First, in 2015, we conducted surveys and we asked 30 teachers at Fujita Elementary School the educational benefits. In the following year, we asked 28 students at the elementary school. Each session, they found the most enjoyable and educational. This year, we asked 4 teachers at the elementary school about the students' understanding of each item. We used this 5-point scale. These are the evaluation items. They include the labor research, environmental issues, and so on. In the same condition as survey 3, we investigated participants about the feedback of the lessons and their educational benefits.
Next, I will talk about our achievements, including survey results. First, survey results. This graph is co-occurrence network using text analysis. It is about the frequency and relationship of words in teachers' comments. It shows that our lessons help increase the students' interest in and motivation to learn a variety of things, including labor research. As a result of Survey 2, the lesson about an amber and surface tension experiment using soap solution were well received by the students. Let's look at the result of Survey 3. Between before and after our lessons, what improved the most was how much the students could understand their local labors. Also, teachers assessed that how the students' interest in the environmental issues have increased. By conducting Survey 4, we can find that our lessons are informative and capturing the students' interests. From Survey 1, 3, and 4, the elementary school teachers highly valued our lessons as well as their educational benefits. Therefore, it can be said that our lessons are successful in enhancing the students' interest in and understanding of the environment. From Survey 2, the hands-on lesson like observing a number and surface tension experiment have left a good impression on the students. However, from Survey 1 and 4, the lesson about labor researching and presentation coaching were highly valued by the teachers. From this, there is a differences between popular lessons for the teachers and the students. Here is summary. Our activities are effective for the environmental education and environmental conservation. We aim to create the lessons that are engaging and memorable for the students, considering that the teachers and the students perceive things differently. In addition, our activities have been recognized not only by the elementary school teachers, but also by out of school. We have won some awards.
Finally, I would like to talk about our future work. Now, we only conduct lessons for elementary school students. However, we would like more people to learn about environmental issues. So, we would like to expand our activities to junior high school students and high school students. However, there are some issues such as limited manpower, budgets, and time. We believe that these challenges can be overcome by expanding our network and sharing our activities. So, if more organizations become interested in our activities, these problems can be solved. To achieve this, we are expanding our network both domestically and internationally. The Libo Symposium has attracted more participants each year. Last year and this year, elementary school students from various regions participated online. Also, we actively engage in international activities. Our joint Libo research with elementary students and international exchange students visiting our school has been highly appreciated by teachers. And also, we hope to expand our network to Taiwan and Thailand. So in conclusion, by making use of our 40 years of cooperation, communication skills, and perspective as high school students, we hope to contribute environmental conservation, fostering the new generation, and international cooperation. Finally, we have two goals. First, we hope elementary school students to become interested in environmental issues through our activities. Second, we hope that international high school students, including you, have become interested in
river environmental issues by doing river research together with us. These are the references. Thank you for listening.
Thank you so much. So next team is from Foon High School, Seri, Malaysia. The topic is the hidden cost of Malaysia's data centers. Let's welcome them.
So make my test. Hey guys, we are from Foon High School, Seri, Malaysia. Our topic today is AI is consuming our water, the hidden cost of Malaysia's AI data centers. Before we begin, who here uses AI every day? Okay.
Our project incorporates all SDG elements, such as quality education, clean water and sanitation, sustainable cities and communities, and responsible consumption and production. As AI technology grows, more and more large-scale data centers are being built to process huge amounts of data. Today, Malaysia, especially Johor, is rapidly becoming a major AI data center hub. It attracts global tech investment and helps boost Malaysia's economy. However, behind its rapid growth lies a pressure that many people overlook. These data centers do not only consume large amounts of energy, but also enormous amounts of water. This map shows the location of data centers across Malaysia. It highlights hyperscale facilities operated by companies such as AWS, Microsoft, and Google. But there is a problem. These data centers need cooling systems that run 24/7 to stop servers from overheating, especially Malaysia's hot climate, and cooling need large amounts of water. One interaction may only use small amounts of water, but billions of interactions every day can create a massive impact. For example, water consumption with billions of use annually is expected to rise even more by 2030. A 100 megawatt data centers can consume around 15 million liters of water every year. With the project like Sedana Tech Park expanding rapidly, the amounts of water used can be imagined as a volume even taller than a KLCC.
So, you might have heard people say that AI is drinking our water. But no, the systems aren't thirsty. What we really are talking about are the data centers powering these systems. And here's the thing, they generate heat, enormous amounts of heat. And if this heat is not controlled, it can reduce system performance or even damage equipment. Therefore, to maintain optimal performance, data centers rely on cooling systems that require vast amounts of clean water. And how does this work? Well, let me tell you. Scope 1, right here, refers to direct use of clean water. In cooling towers, water sourced from rivers, lakes, or even household supplies are used to produce cooled water. This cooled water then flows into a heat exchanger where it absorbs heat coming from the CRAH system. Inside the data center, the CRAH uses chilled water in a closed-loop system to absorb hot air generated by the servers. As it absorbs heat, the water becomes warm and is sent back to the heat exchanger for cooling and continuing the cycle. Whereas on scope 2 refers to indirect use of clean water. Data centers require massive amounts of electricity and are often generated by power plants. Power plants also rely heavily on clean water. But why does this matter to us? The reason is simple. It contributes to the growing problem of water shortages. As mentioned before, the water used are clean, potable water, and a significant portion of it is lost through evaporation. The data center in Johor, Malaysia currently uses 18 to 45 million liters of water per day. This diagram shows that Johor's data center's water consumption is projected to increase dramatically by 2035. Furthermore, the water is no longer pure when it circulates through pipes, as it will be mixed with chemicals such as corrosion inhibitors, biocides, or even heavy metals. This directly impacts the people. Communities living near these data centers have experienced access to poorer quality water as the water becomes dirtier and warmer.
To make matters worse, people are using AI for unnecessary purpose. They ask questions like what color is the sky or what should they eat today. Even more concerning is the trend of using AI to create anime images of themselves out of curiosity. While it may seem harmless, these actions collectively consume large amount of water. Is a generated AI image really more important than preserving our clean water supply? The cruel reality is that many people are still unaware of this issue. This is why we must find solutions to solve these problems. The negative impacts of AI to our environment and our water supply are huge and urgent. But it is not too late. We can still fix things. Firstly, according to 4th SDGs, which is quality education, schools and organizations can hold campaigns to lecturers the general public on how AI function and its actual water usage. By this, they can raise awareness through acknowledging AI negative impacts and its seriousness. Most importantly, they should have educated people to only use AI when it is necessary, by further emphasizing the idea that every job matters.
Next, we propose that AI platforms introduce a water-saving mode to their AI chatbots, which directs the AI to give shorter, more direct replies, instead of generating long, detailed ones that use more water. Users can choose to turn this mode on when using AI to save water, which also reduces the water bills, energy consumption, and carbon footprint of AI companies. It is a win-win situation. In fact, we created a prototype to visualize what this would look like. The same input, high, but two whole different responses. When you're on water-saving mode, you off AI snagging, and get replies that are straight to the point. I invite everyone to scan this QR code and try for yourselves. Please take your time. Thirdly, AI data centers should harvest and recycle rainwater as an alternative to cool their systems. This method is locally adaptable to Malaysia's climate, as Malaysia has a high annual rainfall. The initial cost needed to build the infrastructure for this method is relatively high, but it saves money in the long term and protects our water resources. Hence, it is highly sustainable. Lastly, AI data centers should implement hybrid cooling, which combines air cooling and water cooling. This method increases cooling efficiency and reduces energy consumption. Water cooling uses direct-to-chip cooling. A coolant flows through pipes on top of the chips, absorbing their heat. The heat is then transferred to a separate pipe of water through a heat exchanger. The warm water can then be supplied to nearby residential areas for household use. Air cooling draws cool air into the server room, which absorbs the heat from the equipment. This warm air is then cooled and recirculated into the room, creating a constant cooling cycle. The overall feasibility, impact, and scale of all these ways are huge. We can create actual change by implementing these.
Overall areas for improvements, we should have reached out to the local data centers earlier so that we could have actually visited them in person rather than only observing the exterior of it. Moving on to regional comparisons, I think we should have do more research in how other tropical countries such as Singapore deal with the heat and water waste caused by AI data centers. And next, this project was constrained by a limited time frame. Otherwise, we would have looked deeper into Malaysia's regulations compared to global standards and used economic modeling to calculate the ROI on new cooling technologies and determine whether it is worthwhile. Moreover, We should do more examining in the community impact, specifically in Johor, whether these local data centers are affecting local water prices or access.
In conclusion, this project helped us to understand the environmental impact, especially water usage, while showing us how global technology threats can affect our life in Johor.
We hope that Malaysia's extensive experience in this field can help other countries balance development with sustainability. Thank you.
Thank you very much. So next one is, the next topic is circular waste management through black soldier, egg fly, household food waste recycling, and the planting system from Kuen High School. So let's welcome them.
Good morning to the respective judge and my fellow friends and teachers. Today we'll be presenting on our project on circular waste management through black soldier fly larva, household food waste and recycling and planting systems. Our project integrates both SDG 11 and SDG 12. Now let's have a look at our team, which includes me, Liette, Clara, Ensi, and Kayan, and also our beloved teacher advisor, Madam Fu Chiao Yi. Now let's look into our topic overview. According to a report by SW Crops in 2024, nearly 40,000 tons of solid waste are produced every day, 44% of it being food waste. 82.5% of these solid waste are sent to landfill directly, where landfill decomposition occurs, releasing a type of greenhouse gas that is much more stronger than carbon dioxide, which is methane gas. Due to the fact that our current school waste management systems are inefficient, causing these organic waste to not be properly recycled or reused, a strong need for a sustainable recycling solution in schools is needed. Now let's look into our exploration process. All of this begins from a simple observation on a large amount of food waste being produced in our school every day. As you can see here are real images captured in one of our school canteens during one of our recess periods. For information, our school has a total of 2 canteens, 2 recess periods per day, and 10 food stalls in total, with over 5,000 teachers, students, and staffs. So the amount of food waste generated every day is far more than what you can imagine here. So a question arises in our minds. How can we manage these waste more sustainably? We propose a solution by using black soldier fly as a high-efficiency bioconverter that can convert food waste into frass that can be used as a nutrient-rich natural fertilizer. We've invented a BSF system that can convert these food waste and convert them into frass so that plant growth can be promoted. In our experiment, we've placed this frass into 3 sets of onion plants to test their growth promotion. In conclusion, our project integrates waste management, insect rearing, and sustainable planting. As you can see here is our initial setup for our BSF rearing system. At the top layer, eggs are intended to hatch here, with the young, bright-colored larvae feeding on food waste as they develop. Those that have entered final instar stages will transition in color to a much more darker brown. Established research states that these mature BSF larvae seek for a high, dry, elevated area to prepare themselves for pupation. Hence, we've engineered a 30-degree inclined ramp so that these mature BSF larvae can climb up the ramp and fall into the adjacent chamber that has a dry coconut coir bedding to prepare them for pupation. We've anticipated that these mature BSF will automatically climb into the adjacent chamber, therefore helping in self-harvesting as the mature BSF separate themselves from the young actively feeding larvae. The base layer is dedicated to the adult black soldier fly. Those that have successfully pupated will be placed in here. We've placed an ice cream stick set up so that the adult BSF can lay eggs in there. And this area is also supported by controlled moisture via sprayed water droplets.
We encountered a few challenges in our setup. First, our initial ice cream stick setup failed because the gaps were too large. So we switched, based on research showing they prefer small cracks, we switched to corrugated cardboard, which successfully triggered egg deposition. Early on, we had a big problem. Our larvae kept escaping from the container wall. We found out that when they are ready to pupate, they leave the moist feeding area and look for dry spots. First, we built a 30-degree centered board to separate the larvae from the pupate, but they just crawl all over the place. Next, we covered the container with perforated plastic wraps with poke holes for the first layer and wire mesh for the second and third layer. This allows ventilation. Initially, we use a water sock for hydration in our setup, but the adult BSF laid eggs on it. Then we switched to a small water container, but some adult drowned. Finally, we sprayed water on the container wall instead, providing enough humidity and preventing drowning and unwanted egg laying. In our setup, adult BSF laid eggs initially because the light exposure is a critical factor for mating. We solved this by placing adult container in direct sunlight. Egg production increased significantly and sustainable rearing cycle formed. This is our final setup. Our final setup has been completely redesigned to ensure a more sustainable and biosecurity. Now I'll be talking about the behavior observation of the BSF. At larval stage, they prefer damp environment. At pupation stage, they naturally migrated to drier zone, making separation simple. At adult stage, they require strong and direct light to initiate mating behavior. The leftover larval frass, exoviae, and disease organizers form nutrient-rich organic materials.
Now let's move on to the second batch of our experiment. Here we wanted to take our observation from our BSF larva phase and applied it on our real agriculture task. So now let's see. Okay, to do this, try a few ways. So one of this is we tried to pupate our larvae on 2 different diets. One container with the red mash got fermented food, and another one, as you can see here, with white mash got fermented food waste. So you might wonder why we choose fermentation. So basically, this process essentially pre-digests the food waste by breaking down proteins and lowering the pH value for better nutrients. So our ultimate goal here is to collect a full loop, which is collect the frost from these 2 diets, as I mentioned just now, and apply it as a plant fertilizer and evaluate their real impact on the plant growth. So now, this leads us to the next stage of our experiment, which is our quantitative analysis process, where we specifically track the growth of the green onion over a 21-day trial. Okay, so for our experimental setup, we kept everything strictly controlled. We applied 600 grams of soil, 50 grams of coconut coir, and 6 grams of liquid diluted frost every few days. As you can see, here's a visual proof of our plant. So as you can see here, we can immediately see the physical difference in how they grew. So to sum up, for our data, we can see here, we can immediately, from the data of the February 2nd, we can immediately see that our unfermented group exploded to 32.5 cm with deep and robust leaves, which actually outperformed our fermented group. So now, so actually, you might wonder why actually our unfermented group will outperform our fermented group. Actually, this is about how our microfibers, our microorganisms consume food. So basically, during fermentation, our bacteria actively consume the food that they need for their So it will use up a lot of nutrients that actually will not be, so the nutrients will not left a lot in the frost. So it became a nutrient depleted frost. So in contrast, our unfermented group actually can keep the original nutrients. So this, actually when we use the frost to feed our BSF can, even though, because the frost is very nutritious, so even after the BSF absorb what they need, the frosts are still very nutritious and we can directly boost to our plant growth.
Now I'm going to talk about the scientific discussions of our experiment. So first, our study centers nutrient log in theory. Our unfermented fast group showed a significant growth, outperforming the control group by 91.2%. This is because direct larval conversion of fresh fruit waste has preserved high concentration of immediate release nutrients. In contrast, the fermented fast group experienced a loss of vital nutrients during the pre-decomposition heating phase. Next, when observing the crops, we witnessed a clear triumph of plant quality over quantity. While the control group produced a higher total leaf count, the plant suffered from ethylation, showing due to nutrient deficiency. However, the fast group produced robust stalks with higher chlorophyll and superior photosynthetic efficiency. Next, we unlock a powerful biostimulant effect. The presence of chitin in our larva exuviae acted as a natural growth promoter, which improves competitive nutrient uptake. Of course, these are the practical takeaways which makes our project truly special. First is we engineer a scalable and user-friendly BSF rearing system. And we utilize accessible bedding materials such as corrugated cardboard and coconut cord to prove that we can adopt this circular system in households, schools, and communities. Of course, true science strives on continuous improvement. Next, we hope to solve fertilization consistency by replacing with an automated drip irrigation system, precision of growth tracking by replacing it with a sensor-based daily tracking to capture precise growth curves, and also see how substrate variability impacts fast quality. And this just shifted our mindset because we can turn the smelly nuisance, which is the frost, into precious raw material to create a circular bioeconomy. In our school, we hope to fully integrate into a campus vertical farm supported by a zero-waste infrastructure to produce 100% of our daily organic canteen food waste to maintain our campus landscaping at zero cost. Now, this is the end of our presentation, and we thank the organizers for this wonderful learning opportunity. Thank you.
All right, so all for your presentations. We believe that you are now eager to get some constructive feedback to improve your research. So please join me in welcoming today's commentator, Dr. Du Yichun. Professor Du Yichun, would you please give us some words, give them some feedback?
Wow, very impressive. So, as the mentioned from the church of the chief of the judge, the Professor Chais mentions, he said, all of your research results is as strong as the university research. So it's very impressive and inspire me. Actually, because of the rule, so I cannot ask my real, because I just wrote some presentation. I'm very interested and there's some questions. Maybe if we have an opportunity, maybe we could talk for the more detail about each project. I hope I have this change to do that. But I think all of that is the presentation is very, very good. And I think that this is a very good opportunity. Not only presentation, your research. You can also learn the other research teams, how to they do presentation, their work, and how to they to prepare their research. I think it is a very good opportunity to learn more about from the other country or their research results and their experiments. Okay, that's my little comment, and maybe the next session I could give you the comment. Okay, thank you.
Thank you again for the constructive feedback from our commentator, Dr. Du Yichun. So now it's time for a short break. Desserts and beverages are ready for you to enjoy outside the venue. Please be noted that eating and drinking is not allowed in this venue. The next session will begin at 3 o'clock. Let me repeat that. The next session will begin at 3 o'clock. So please be seated by then. So see you later. Enjoy your tea break. May I have your attention, please, for the students, for the teams in the next section. If you still want to do the last revision of your PPT, would you please come forward and go to our staff to do the last minute revision of your PPT. For the students, for the teams in the third section, if you want to do the last revision, the last minute revision, you can come forward and go to our staff to do the last minute revision. Anybody?